się.
O, chyba zaczęliśmy, słuchajcie, jesteśmy live od już sekundy, więc myślę, że przełączmy się na język angielski, dlatego że dzisiaj jest z nami sporo osób, kilkanaście osób niepolskojęzycznych na pewno, więc hello everybody, welcome you guys with AWS User Group Kraków chapter. So today we have our first meeting on the new tool called StreamYard, and I hope you enjoying the view. If there is any problem with connection or anything, just give us info on comments. Well, what to say, Szymon? Szymon is frozen sometimes, so don't worry. He's alive. He's well. It's just the LTE, you know. So be cool with that. Okay, so let's start. So what is AWS User Group? AWS User Group is a group of users who dealing with technology from AWS. We're talking about a lot of stuff, you know, from EC2, Beanstalk, from ECS, whatever you do with AWS, you can talk about it. You can tell to your community, to your local community here in Kraków or Małopolska region, what you're doing and about you know, things that are going well with the tools that you are using, some kind of things that not going well at all, you know, because sometimes the technology, it's, you know, they have pros and cons. We want to be super open about it here. So let's talk about plus and minus of the technology. And today, our meeting, it's supported by our Patron, which is a Grape Up, and our partner, which is Accenture. And today, from those two companies, which have here in Kraków some headquarter, no, maybe not headquarter, branch office more like, or Grape Up is headquarter actually, I think, here in Kraków. Yeah, headquarter. And Accenture is it's a huge branch office. We have two marvelous specialists, so Michał from Grape Up and Cosma from Accenture. And well, this is the first thing. And another thing is that because of our partners and patrons, we are able to provide you guys some refreshments, some pizza vouchers probably, or whatever, vouchers for anything what you want to spend for. And what you need to do to get those, you need to fill the oh well, let's see if the first comment is here. Oh my god, I'm so curious. Oh yeah, order pizza, of course. The first comment, you know, it's about pizza. So you go in there, guys, and you fill the form, and there are two rules regarding that. There are not, you know, you can fill it, and if you will you know, make a mistake, you will get a voucher still. But if you will reply with the answer that is correct, on the end of the meeting, we will make a draw, and you will be able to get some AWS vouchers to buy services from AWS. So not Amazon vouchers to buy dress or pants or wherever. No, you will buy AWS services for that. But I will not take more of your time. Here with us it's Szymon, but he already left because the cell phone collection, you know, here in Kraków we have winds, you know, smog and wherever, and you know, area of cellular connections sometimes is going down. So Szymon is a co-leader. I'm a leader of AWS User Group. My name is Maciej Lelusz. I'm leading this group since, I don't know, couple years, yeah, couple years for sure. I have no idea how many, but it was a lot. So first, our presentation, first presentation that we will be able to deliver you guys, it's presentation from 𝐒𝐿 Kapiński. He will talk a little bit about serverless architecture, and the serverless is a subject that is going over and over through our channels during our meetings. I'm really curious, Michał, what you want to say. Michał, Grape Up, the stage is yours. Please feel free to say something regarding this marvelous subject that's serverless for our users here. Do you hear us, Michał? Yeah.
Hello.
And the presentation is there.
Hello.
Good. We see your presentation. Yeah, perfect.
Okay, awesome.
Great.
So hello, everyone. My name is Michał. I'm a senior software engineer and AWS Certified Solutions Architect, and I work at Grape Up, where we specialize in cloud native and AI technologies. And today we're going to talk about serverless architecture with a specific emphasis on AWS Cloud Development Kit. So let me start with a little story. So there was a time when the world was inhabited by the creatures known as monolith applications. Those beings were enormous, tightly coupled, difficult to manage, and highly resource-consuming, which made the life of tech people a nightmare. Out of this nightmare, a microservice architecture era arose, which was like a new day for software development. Microservices were small, independent, communicating with each other through their APIs. Each microservice could be developed in a different programming language, best suitable for the job. This all provided a great deal of flexibility for developers. The biggest benefit of the new approach was scalability, coming from the possibility to scale each microservice individually based on your resource demands. The microservice era was a life change for the IT industry. However, microservice architecture still posed a huge challenge in the areas of deployment and infrastructure management for distributed systems. What is more, there were scenarios when it was not as cost-effective as it could be. That is how the software architecture underwent another major shift, this time towards the serverless architecture epoch, which was like a pure nirvana. Okay, here I got a bit ahead of myself. Let's look at what exactly is this serverless and if it really is that great. So what does it mean to go serverless? Does it mean that the servers are completely gone? A bit paradoxically, not really. Both server hardware and server processes are present exactly as any other software architecture. So where are they? The difference is that the organization running a serverless application is not owning and managing those servers. Instead, they are part of the cloud infrastructure of the cloud provider. And how does it work? So serverless applications mostly make use of third-party backend as a service and/or function as a service platforms. And we'll talk about those in a minute. But first, let's have a small recap of all those hot abbreviations popular in the cloud environment nowadays. So we have infrastructure as a code as a service, IaaS, where we get virtual resources and we can manage them. So we get virtual machines, for instance, EC2 on AWS. There is platform as a service, PaaS, where we get full runtime environments for our applications, and we do not manage the infrastructure behind it. So for instance, Heroku or Salesforce. Then we have SaaS, software as a service, which is a business model where software is licensed and delivered to end users. Here we can talk about Gmail, Facebook, Office 365. And then we have BaaS, which is backend as a service, and FaaS, which is function as a service. And we'll talk about those more at the next slide. So backend as a service is a cloud service model where the cloud provider delivers services responsible for the server-side logic for what usually would our backend do. And this logic can include stuff like database management, cloud storage, user authentication, push notifications, etc. In this approach, client applications, instead of talking to the dedicated servers, so to the dedicated backend, directly operate on those cloud services. Then we have function as a service. And in function as a service, we still write our server-side logic, but instead of manually deploying it into physical servers, we upload our code or write it directly in the function editor. Then we configure triggers, which define when our code should run, for instance, on specific HTTP requests or as a part of the scheduled job. And then our code gets executed whenever any of the triggers fires up. One of the most popular implementations of function as a service is AWS Lambda, but each of cloud providers has its own corresponding options. And in this presentation, we will explore the combination of both backend as a service and function as a service approaches, as most enterprise-level solutions combine both of them into a fully functioning system. So let's now take a look at an exemplary serverless architecture. So this is a relatively simple design of a user management system. It utilizes Amazon Route 53 for DNS resolution and Amazon Cognito for authentication authorization of access to our API. Then we have API Gateway, which deals with all the routing, request throttling, DDoS protection, etc. API Gateway also allows us to implement custom authorizer logic if we can't or don't want to use Amazon Cognito. And behind that, we have the business logic layer, which consists of Lambda functions. If you're used to microservice approach, you can think of each Lambda as a separate set of controller endpoint and service method, handling a specific type of request. Lambdas further communicate with other services, such as databases, caches, config servers, queues, notification services, or whatever else our application may require. The presented diagram demonstrates a relatively simple API. However, it is good to bear in mind that the serverless approach is not limited to APIs. It may also be used for more complex solutions, such as data processing, batch processing, event ingestion systems, or whatever. So let's now look at some comparison of microservices and serverless applications. So microservices divide applications into small, loosely coupled services that could be developed, deployed, and maintained independently. Those services have distinct responsibilities and can communicate with each other through APIs, constituting together a much larger and complex system. Up till this point, serverless does not differ much from microservice approach. It also divides a system into smaller, independent components, but instead of services, we are usually talking about functions. So what's the difference? The microservices are standalone applications, usually packaged as light containers, and run on physical servers, which you can access, manage, and scale if needed. Those containers need to be supervised or orchestrated with use of tools such as Kubernetes. When you deploy microservices, they are always active, even when they do not perform any processing on the servers provisioned to them. So we need to pay for those resources even when there is no traffic on daily or monthly basis. Now, in comparison, when it comes to serverless functions, you only write your function code, and function as a service provider handles its packaging, deployment, and execution. The cloud platform deals with scaling, so we have automatic scaling, without showing you or giving you access to physical resources required to run it. Then serverless functions are only brought to life for the time of execution. So if there are no requests, they do not use any resources. Hence, we pay only for the resources on demand according to our usage. So what are the pros and cons of serverless? Let's start with some pros. First of all, pricing. Serverless works in pay-as-you-go model, which means that you only pay for those resources which you actually use, with no payment for idle time of the servers and no infront dedication. This is especially beneficial for applications with infrequent traffic or startup organizations. Then we have operational costs and complexity, because the whole management of our infrastructure is delegated almost entirely to the cloud provider, so we don't have to spend our resources on that. Servers also provide scalability by design. So serverless applications are scalable by nature. The cloud provider handles scaling up and down of resources automatically based on the traffic. And we can get rapid development with serverless because no infrastructure management is required. So that makes it much easier to set up new projects. But of course, as any approach, serverless also has some cons. So let's look at some drawbacks. First of all, it's a much less mature approach than microservices, which means a lot of unknowns and spaces for bad design decisions exist. Then, serverless introduces higher architectural complexity because serverless functions are much more granular than microservices, and that can lead to higher architectural complexity, where instead of managing a dozen of microservices, you need to handle hundreds of Lambda functions. Then serverless usually means specific cloud provider lock-in, because they are cloud provider-specific solutions. And usually we prefer to avoid that. Apart from that, some services, some function as a service and backend as a service platforms can have some limitations, such as maximum number of concurrent requests, memory timeouts, etc., which are often customizable, but only to a certain point. And last but not least, serverless applications usually need to deal with cold starts. Cold starts mean situations when the response is delayed because of the fact that the new instance needs to be boot up and needs to copy the code of our application to run it before execution. There are ways to deal with that, but we're not going to tackle it during this presentation. So I said that that serverless has a very preferential payment model. And how much does it really cost? So it's really cheap. Here we have some exemplary costs. So for instance, for API gateway, we pay only $3.50 for per 1 million requests. For Lambda function, 20 cents per 1 million requests, and for SQS, first 1 million requests is free, and then we pay 40 cents. So it all seems very little, and it is cheap until the point it's not. So there are some scenarios, some systems, which may require higher traffic. For instance, there is a real case described in this article. You can see the URL too, which had traffic of 5 million requests per hour. And that, taking into consideration the cost of API gateway, $3.50, resulted in more than $12,000 per month only for API gateway. So in this scenario, it would probably be much cheaper to have a load balancer and a couple of virtual machines. However, you also need to take into account the costs of infrastructure management, which in microservices require and serverless usually don't. So when serverless is right, in my opinion, there are a couple of scenarios for that. First of all, prototypes, MVPs, proof of concepts. When you need scheduled jobs, or systems when you have systems with infrequent traffic, for data and event processing applications, and often for simple system integrations when it might be much easier to write a simple Lambda instead of new service. So at this point, we know quite a lot about serverless computing. So now let's take a look at how we can create our serverless applications. First of all, we can do it manually through the cloud provider's console or CLI. It may be a good educational practice, but I wouldn't recommend that for real-life systems. Another well-known solution is using infrastructure as a code, such as AWS CloudFormation Service. However, in 2019, AWS introduced another possibility, which is AWS Cloud Development Kit, AWS CDK. And AWS CDK is an open source software development framework which lets you define architectures using traditional programming languages. We can use languages such as Java, Python, TypeScript, C#, Go, or Ruby. And AWS CDK utilizes CloudFormation behind the scenes to provision our resources in a safe and repeatable manner according to infrastructure as a code principles. So how does it work? So AWS CDK provides us with high-level pre-configured components called constructs, which we can use and further extend in order to build our infrastructure. When we build our application with those constructs in any of the languages supported, we simply run a CDK synth command, and our code is compiled into CloudFormation template. And later on, we can run CDK deploy to deploy our serverless application. So now let's look at some code. We'll look at the definition of a more or less user manager system, which we talked about before, some simplified version. So now I'm going to move to IntelliJ, and I'm going to enter presentation mode. OK, so we have three most important directories here. Let's look first at the bin directory, which has a single file. And this file is an entry point to our serverless application. It simply creates a new CDK app and then initializes stack. So lib directory includes all the definitions of our infrastructure. So we can just go to the user manager serverless stack, which is an entry point for our definition of our infrastructure. So we can see that it extends from the stack construct. This is provided by CDK library. And here we just provide some properties of our stack, environment variables, and then we instantiate specific members of our stack. So in this case, a Cognito construct, because we create a Cognito user pool, a user's DynamoDB table, a Lambda construct, which is a construct which encompasses all the Lambdas in our architecture, and then finally API gateway. So now let's dive into some of the definitions. here. So for instance, let's look at users DynamoDB table, which is probably the simplest one. So this is the definition of users DynamoDB table. It simply extends the table construct and provides properties such as table name, partition key, removal policy, and table ID. And this is enough to create a DynamoDB table with AWS CDK. So then we can look at Cognito construct. This one is much more complex, so I'm not going to go here much into detail. But again, we use here we extend a construct, and we use objects from CDK library for creating a user pool, for creating a resource server, user pool client, and user pool domain. And later on, we export some values so that we can access them easier after creation of our stack. So now let's check out Lambda construct, so the definition of our lambdas. This is a construct which encompasses creation of all our lambdas. So we have 5 lambdas in total. And in here, we are instantiating our lambdas and granting them permissions. So for instance, read or write permissions to our users DynamoDB table. If we go into, for instance, create user lambda definition, we can see that this one extends function construct. And again, we provide some properties for the lambda function. So for instance, here, we provide runtime, timeout memory size, and we activate the tracking. Then we specify in which location our code is located, code for our handlers, and then we define the handler entry point. We can also add some other properties such as layers, role. Here we have role for just for Lambda execution, but we could require some more IAM roles. And we can pass some environment variables. So for instance, here users a table, so we can access it from our Lambda. And then in the end, we have API gateway, where we create our API. We define the authorizer, and we define paths, and we map them to our Lambda functions. So that's more or less the definition of our infrastructure. Let's now look at some business logic code. So this one is located in the lambdas directory. And let's look at some handlers. So for instance, create user handler. So this is the simple handler of the Lambda function for the create user functionality. As an input parameter, we get API gateway event, which includes properties such as body, header, HTTP method, all the things we might need for the RESTful API. All the rest of the logic is basically the same as in any other application. So we just get the body, get the parameters, and we handle it. So we process that with our services. For instance, here I have a user service which operates on DynamoDB. So this has no serverless specific logic. So now let's try to compile our codes. So I can run sync command. This is going to execute CDK sync on our application. And after that is executed, we should get another directory here, which is CDK out. That will take a moment. I guess, oh, OK. OK, so just my directory doesn't refresh here. But if we do ls, we have another directory, which is CDK out. And in this directory, our CloudFormation template is present. So then we can run npm run deploy. And this is going to run CDK deploy command, so deploy our stack into AWS. I already have my stack deployed, so this is just going to compare the differences. And if there are none, it's not going to do anything. Otherwise, it would deploy the stack. But that takes some time, so I don't want to do that. So now let's go to AWS console. I need to leave the presentation mode, and now AWS console. So if we go to a CloudFormation service, we should be able to see our stack. And it's here, it's user manager server stack. We also have CDK toolkit, which is the stack required to run CDK applications, and it's installed during the CDK setup. In our stack, we have the stack information, all the events performed on the stack, resources, outputs, parameters. And here we can also see the CloudFormation template, which created our stack. This is the same one as is present in CDK out after the 𝐶DK_synth command being executed. And now we will see all the resources created by our CDK command in AWS the same way as for any other application. So for instance, we have our API gateway, and we can perform operations on it. So here I have a simple Postman collection for getting the token for my resource server. I can create a user and retrieve the users, for instance. So all the regular stuff. Oops. Yeah. So that's it from my side. And if you would like to access the code, it's available on my GitHub. You have a link here. Yeah. Otherwise, I'm giving the voice back to the studio.
Okay, good. Thank you very much. We have some questions though. Are you ready? Philip, it's giving them. So API gateway pricing depends on integration type that the apps use. $3.5 for 1 million requests is the price for REST API integration. HTTP API is much cheaper. Do you have experience with this integration type?
I haven't worked with the HTTP API per se, but I think it only has something like the pass-through mode. So the real REST APIs usually require the more expensive version. At least that's what I believe. But
okay, so no pros and cons because you didn't work with that. I assume.
Yeah,
Michał.
Yeah, I haven't.
All right. So Philip also adding something like, and it's not sure that it was mentioned, but during the presentation, you said node models layers. Yeah, just so, you know, they look. Watch out for their users. Their users. So come on, man. As you will see somebody else presentation, also will point there. So bring it on. Bring it on if you can. Perfect. Node models, layers.
So node modules, we define them so that the package, including our Lambda code, is smaller. Mm-hmm. And then, do you still see my screen?
No. I think the studio needs to do that a little bit. Or Michał, oh yeah, you share it.
Now,
yeah, it's going on.
So we define node modules, and then we pass them to the Lambda function. So that's the package of the Lambda is smaller, and that leads to the situation where when we go to the Lambda service, a moment, and go, for instance, to the create user Lambda. Here we have the source code of our Lambda function. And if we didn't define the node modules, it would be too big to be viewed in the Lambda console. Mm-hmm. We wouldn't be able to, for instance, do
small change.
Important stuff. Yeah, so for instance, we wouldn't be able to add a console log when we want to debug something. So that's basically
right. So that's why you make it smaller,
and then node modules are they are somewhere. You can view them somewhere. I'm just not sure where exactly right now. Here, AWS Lambda layer. So this code is just there, and it's imported by the by the Lambda function.
Okay, perfect. So no more questions right now. If you can stay with us, Michał, it could be perfect.
Sure, I will.
Because maybe some other questions will pop up on our YouTube transmission. So again, thank you for our patron, which is Grape Up, and because of them we are able to stream live for you guys. And right now, it's time for invite on scene Cosma Fulawka. He's AWS Practice Lead in Data and Applied Intelligence in Accenture Poland. Accenture is our partner, and because of them, you get the best refreshments ever, because you can choose them by yourself. It's not the catering on the conference. It's that kind of a pro. When you're thinking about it, this is some kind of a little plus of the conference online. We have a little bit of shaky screen in a moment, so let's wait a second. We will get on view. Yeah, we have screen of Cosmo on screen. Perfect. We see the trees, we see the Winterman, and absolutely is different.
Can you see now me and about me?
Perfect. Yeah, perfect.
Yeah.
I'll let's stage for you. So Cosma will talk a little bit about how to control cost of wide-scale, high dynamic data processing system placed in AWS cloud. So it's going to be a lot of things regarding data analytics. So Cosma, the stage is yours. We see your presentation. Thank you.
Okay. Hello, everybody. So yeah, as Maciej said, I am a AWS Practice Lead in Data and Applied Intelligence in Accenture Poland. I'm technology architect, cloud architect. I've got over 20 years of experience in application and data architectures, development processes, and complex IT delivery. I was engaged in various projects as an architect of client-server distributed systems in banking, finance area, focusing on the components and services architectures and how to deliver them in the desired quality. And in the last 5 years, mostly I am focusing on the cloud data architectures in the AWS and Azure. Also for various projects in Accenture, but I had let's say a break in the TomTom when I was responsible for running a wide-scale production system, AWS based, and this experience was, let's say, mind-changing in my life, because I'm passionate for data. Numbers are talking to me, and instead of Excel, I prefer the more visual style, like a business intelligence, and this is what I'm gonna talk about here. And yeah. And privately, I'm the big fan of snowboard, metalcore, longboard, and World of Tanks. So if you want to, we can play together. Okay, let's go to our topic. This is the cost control in AWS Cloud, and I will show you a bit how to handle it with some success. So let's go with those 300 slides I prepared. Of course, this is the joke. So, what you can expect? For starters, the problem statement, why controlling costs in the cloud may be a big deal. So how to handle it, and why the AWS Quickside is a business intelligence tool I've used. Then I would like to present the common architecture in the cost analysis, the data which is behind, the charts, and at the end of this presentation, the demo. I will show you how it works, and I will play it for questions and answers. Okay. Yeah. So what's the problem with the cloud costs? Yeah. It's all about the complexity. In a very small, simple architecture, everything is visible because it's small, and we usually know what we are paying for. Let's take a trial account as an example. We can set a budget. We can set a triggered alarms on, for example, 20%, and hoping that during the trial period we do not cross the pay line, which is very fast. Believe me, if you set the wrong resources. Or in the simple system, for example, 2 databases and a web server, which we can use in the HR system. And in the final bill, we can find simple aggregation, how many money we can pay for this, and what we can expect in the next month. And this is because of the low traffic, we can easily foresee future costs, and mostly in this scenario, we are playing on demand. So if we are using, we're paying for it, no big deal. But in the high dynamic systems, everything is more complicated because of thousands of elements, and the complexity goes up with every level of connection between them. Yeah, so complex system may use various machines and various services to do similar things. For example, in the big organization, one team may use exactly for the same job this machine type and the another other, and this will be reflected in costs. And at the end, the effect will be very hard to foresee, especially in costs. Yeah, also complex architecture may introduce some hidden stuff like inter-zone or inter-regional data transfers costs. Or maybe there will be too much costs when we're buying too much on-demand stuff. And if we are buying too much, maybe we can just use some reservation. But at the end, if those reservations will be incorrect, or system doesn't utilize them in the 100%, more costs may appear than expected. So with a proper tool, finding out what's happening will be ineffective. And even if we apply some healing plans, and if those plans fail, this will be very frustrating because basically we'll be blind and have no idea what is going on. Yeah. And the second thing, when there is a complex architecture, there's a complex cost I have mentioned before. So what problems may occur? What we need to find out to be sure that we know all about our costs. First, untagged resources. Best practice says that use tags whenever you are creating the resources. This is basically obvious, but this is the matter actually of an organization and the discipline or tools. In the real world, it may occur that both are not working, and we end up with like a 1/3 of cost tagged as unknown resources. And this is very uncomfortable when you're paying, for example, $1 million bill each month. So you know what to find and what to pay for. The second, reservation utilization. We bought some machines in the reservation to make saves or over on demand, but somehow it may happen that we are paying for so-called blue sky. The blue sky is there when the machines are doing basically nothing but fan spinning, and on-demand costs are not dropping at all. And we thought that using the reservation it should drop, but it isn't, because some other parts of our organization may use still on-demand. Third, not use the resources at all. A bit similar to above. For example, everything is closed in holidays or in the weekends, but we are paying. Why? We need to find it out. Fourth, in the big organization, there is a structure in KRK and separate budgeting between teams or departments. Some organizations will use much more costs than others, much more resources than others. So we're paying much more cost for them. Or just for users, some of them may use too much resources and will generate too much bill. Okay. Fifth point is the multi-account bills. Similar to above, in big organizations, we usually use few accounts than one. So if you are settled on the multi-account structure, we would like to see what is happening with our cost. And in that case, mostly, we got some organizational discount. And we would like to see how this discount plays with our accounts. And sixth, combined costs. Sometimes AWS bill is not the only one we pay. For example, we can use third-party services with their own payments, like a Snowflake, Databricks on top of our AWS architecture, cloud custodian, etc. So we would like to see how those costs are combined together on the one simple report at the end. Yeah, and last but not least, overpaid but old resources. Some components of the system may be used in the good way, but there may be the old services used. For example, old types of machines, and when AWS introduces the new one, for example, 2 times cheaper and 2 times faster, every cost controller and architect of the system would like to use them instead of the old one to have a lower cost and better performance. So this is the typical iceberg scenario. We may see part of it, but the real horrors are beneath under the surface, and I would like to show how to find those horrors. Yeah, it's in the huge complicated build, it's not easy part, so we need to find the right tools for the job, and we may have a couple of them. So first, AWS Cost Controller and other available services for cost control are basically good and basically are mandatory, but they may be insufficient in the big scale because of mostly in the big scale they're hard to operate and to find and to explore. So there should be a better way. For example, we can use third-party services oriented for explanation our bill, like a cloud checker here as an example. But sometimes this may introduce another problems. For example, the third-party services cost, this is the additional cost for me. And in my experience, the service may often fail when the traffic in my infrastructure is too much and the bill generated is too high. Sometimes I even overloaded the service, and this was, let's say, the cure was worse than the illness. So I wanted exactly to see how my architecture look like in terms of costs, where to find most of costs, when and by what those costs are generated. So Excel was the answer, and as you see on the right side on the lower, Excel may generate a very nice pivot tables with some heat maps when we can see immediately the cost drivers burning red in this scenario. But Excel itself has some limitation. For example, still the scale. If the bill is too big, the Excel works too slow, or even is not able to ingest the data because the limitation on the rows. So slicing the bill into 1 week's chunks is not an option, because I would like to operate on the full month scale to see the cost in the full month. So at the end, we may end up with some business intelligence tools, for example, Power BI, Tableau, or Quickside. And me personally, I was a very big fan of Power BI, so I used it. But we are on the AWS, right? So what if I cannot use the Power BI? And this tool has some disadvantages. For example, I've used the Power BI desktop, but this tool in the big data set requires a very strong machine. So basically it works very slow. The second one, I would like to publish dashboards or cost report to my stakeholders on the project. And to do that, I can do in the couple of ways. First, generate the PDFs and send them by email, but this is, let's say, this is far from automation. So I'd like to buy a server for it, and then I need the Power BI server for it. And this is, of course, additional service, and sometimes adding additional costly service to the organization, it's not an option. And third, the let's say the most close to us, Power BI works only on Windows. So when I changed my machine into Mac, there was completely disaster because I have nothing. I have no tool to work. And of course, setting some virtual machines with the Windows image was really not an option because of the scale of the data set and the resources on the machine. Yeah, so the answer was very close, and this was AWS Quickside. Okay, and for a quick description, AWS Quickside is a managed service by AWS, and moreover, in AWS cloud-oriented organizations, this service may be available for our user in organization without any additional costs, like a normal AWS console. And in terms of the tool to getting the sense from the build data, the Quickside gives me exactly the same ability to do thorough and accurate data mining as a Power BI. Even generates the same reports in form of PDFs. So every time I can send them also as a separate documents. Of course, this service has additional costs, but of course, in the big organization, this cost is a part of operating stuff, and okay, we can use it. Yeah, and for, let's say, if you are starting something with Quickside, AWS allows you to set up Cost Explorer with some data generation for Quickside, for Athena, and for Redshift. So this tool will be using Cost Explorer generated automatically data sets with the costs, but those costs are not good when the bill is still too big. Okay. Yeah. So let's dive into this Quickside tool into the details. And this is the architecture reviews. It's a simple one where data basically reside in the S3 bucket, and from this S3 bucket, I mean this consolidated cost, Quickside dashboard will be reading our data. But as I said before, there may be some additional requirements, like to combine the costs first, or analyze them first, or aggregate them first. So we need to build some kind of a ETL data pipeline with some transformation inside. So our costs at the beginning land into another S3 bucket. I call this raw cost bucket. And then transformation, I do some transformation with those data to have the data set I will be using in my costs analysis in the Quickside dashboard. So about transformation, where is handy, when is good, what is about this transformation? For example, yeah, we have a multiple account architecture. So it means that every time where we have more than 2 accounts, basically we might end up with the question, what was this account again, when people see the numbers. So I suggest to transform account's number into something meaningful, like in this example, main account or experimental account. The second, aggregation into days, because usually costs data sets are seconds or minutes or hours oriented. Sometimes it may be good, but for overall cost analysis is too much data at the end. So I would like to aggregate them into days, because it's better for let's say normal usage in the future. Yeah, and third, as I said, data consolidation from various data sources. So I can combine here different data sets, some comma-separated files, some JSONs, whatever the bill comes in. Okay, and the very last thing here, technical issues with the data format. Unfortunately, Quickside in some cases doesn't accept, let's say, obvious data formats. And I discovered that to have the correct data, we need to clean those data a bit to give the, for example, dates, the format which is accepted by Quickside. And for example, in our part of the world, when we are using, for example, format like day.month.year, this format is not accepted by Quickside. So he doesn't treat the date as a date, but treat the date as a string. So let's change it into this year-month-day format, and the problem will vanish. The second one is the comma dot problem. So every amount, if is in the American format with the dot, is accepted. Format of the cost with the comma is not accepted at all. So the same here. Just to prepare right format on the entry. Okay. Yeah, this huge set of very small charts. This is the dashboard I will be explaining further. And this dashboard allows me to take out all informations I need about my costs. So what I'm looking for. First, how the costs are presented in time, how it looks in time. And because of multi-account, basically I need blended and unblended rates or costs, which basically means that in the multi-account setup, we got some discounts on the organizational level, and this comes with the blended rate. Yeah. And why in time? Because I need to be sure that it looks right according to my expectation. For example, I pay my bills on the first day of the month. I mean, bills like a partial upfront or something. And I can expect some peaks days during the month. So I expect their peaks of costs. And beside the time, I need to see how those costs look like from the accounts perspective, from the usage type perspective, usage type / the machine type, exactly, the purpose and environment, and you can set here every tag you want. So basically, this is the tags I used, like to see what for my infrastructure works. What is the user activity? How many instances are concurrently running in my infrastructure? And the whole point of this dashboard, how to find correlations between data. And in this dashboard, every element is clickable. So it allows me to do some data mining and to grab the sense of the, for example, some abnormal situations in costs. Okay, so briefly, I will go through each diagram and I will say, on each what I'm looking for, and then we comes to the demo, and you will see it's live how it works. I think it's amazing. Okay, the first cost aggregations divided into blended and unblended costs divided by account and set in the timeline on the right. Yeah, the second one, sorry, yeah. Okay, the second one, costs versus account versus purpose, composed in the placed in the time, and what is the composition of each of my account. By composition I mean this right hand side percentage chart. And this timeline gives me the first glance of how my accounts are set up in time. So as you see here, the main accounts is really main and big deal here, and with some abysmal experimental or isolated environments. Okay, the second one, heat map and another composition. Heat map on the left is a very handy tool. It basically gives me perspective on the everything I put there. I put it here, costs and purpose spread in time. So I immediately see what was really means the busy day, what was happening there. It's basically the reflection of the pivot table I used in Excel. Yeah, and the composition, cost versus purpose, also in time. Okay, another one is instances on each account versus purpose, also in time, and the composition of it. And this chart shows real instance activities used by daily. So if combined with the costs, it shows what exactly is happening during particular days. For example, a lot of cheaper instances, and what is the cost behind, or few expensive ones because the cost was the same, exactly the same day, but the real usage was completely different. So this is very, very helpful for such investigation. Yeah, this is very important for everybody who is using reservations. This is machine types versus cost analysis versus cost. Actually, I put it here, the usage type, and this usage type shows me every machine with the type of usage. For example, if I see the heavy usage, it means that this is the machine I've reserved. If I see box usage, it means that this machine is bought on demand. If I see additional costs, like a data transfer, this means data transfer between availability zones, the part which may occur, but in the huge environments, we should avoid it like a hell, because sometimes it's may introduce like a 10 or 15 or 20 additional unexpected costs to our bill. And of course, we can see every machine type, like for example, i3 2x large or i3 i8x large, and so on and so forth. So this is the chart which shows me the main drivers of the costs. And some numbers aggregation, like just to see in the one glance of the eye, what are exactly costs of instances divided by account, divided by purpose, how it's spread in time and on the accounts. And at the end, the same machine type chart, but this time filtered. And this is for tracking the exact machines I bought in the reservation. For example, I know that I bought some i2s or i3s, So I would like to see them on the separate charts. And I expect here mostly heavy usage, but sometimes may happen some kind of box usage. So, okay, I reserved some machines, but every time I also see some on-demand usage, on-demand bots. Yeah, so box usage, and this is very healthy situation. As an opposite, for example, I've reserve some R5 machines in the very huge number, and every time I see some costs on it, and there is only heavy usage in my bill. So this means that probably I've bought too much. So I need to check in the utilization chart in the Cost Explorer to find the real usage of those machines. Of course, I can incorporate to this dashboard the usage from another data source, and I will be see it on this dashboard immediately. And at the end, how the costs looks like divided by users, to see who is generated, who is the most expensive, not employer, but maybe most active. Or sometimes, of course, we can find out that some person is generating a really big cost, because sometimes maybe he or she doesn't know how to set up machines, or he sets up wrong type. So this is the very, very important part of this chart. Okay, so let's go to the demo. Wait a minute, wait for it. Wait for it. All right. Please tell me if you see the browser. Halo, halo?
Widać jak najbardziej, słuchaj. Jakbyś jeszcze raz mógł udostępnić, to będzie już... Tak załadował się, widać przeglądarkę, więc śmiało.
Okay. Okay. This is the example dashboard. So you can see every chart at once. And for example, if I want to find out how many costs are on this experimental environment, I immediately see the unblended rate, how it looks in the time, what is the composition of it. This is exactly the same chart as before, because it's divided by environments. How it looks like a heat map, another composition, machine type used, another composition, table data, and for example, users. And if you click for something, for some element, this will go level down. So here, this will be another detailed data, but only for the division user placed on, experimental environment. Of course, we can reset this and start our analysis again. For example, just let's look what is happening this day, so we can see. Come on, that's mainly activity on the main account. This is our composition. So this was a really busy day. Maybe this time, because of the huge amount paid this day, probably there was some additional costs as a part of the partial payment. We can find it out seeing the machine type. And machine type, usage type, part of the dashboard beside the machines, like a heavy usage, box usage, also shows something without any description, like a empty. And basically empty means in our bill in this type that this was a payment for reservation. Yeah, and in this day we can see also what users were using those most active. All right. And at the end, let's say we can check, for example, this day. It also will generate only the daily information. Yeah. Or for example, this part, when we see some difference between blended and unblended, we can find out what it really means. Yeah, so this unblended was a difference on the M4 RX large machines, probably because it was added from the discount here. Okay. So this is what I wanted to show you. So if you have some questions, go ahead. I can be still on the demo. So that's it from my side.
Thank you very much for your presentation, Cosma. I think Łukasz asked one question, but after that you, I think, you showed the answer on screen. So there is no more additional questions. But I have a private mind question. So when it's regarding a data amount, what kind of data amount you dealing with? Because you said that, in small setup, it's easy, and the billing data flows, but that environment that you show us, it's kind of, I think, pretty big environment.
Yeah,
what
actually,
kind of big?
It's hundreds of terabyte, terabyte of data. Mm-hmm. Actually, they're relational, and of course, we can go further if we are talking about the petabytes, for example.
Sure.
If we are running Databricks clusters, when we are operating on the data lakes with the, for example, mm-hmm. Medical data, okay. There were a huge amount, like a petabytes, and when are run hundreds of cluster nodes in the big data system, this starting to see, for example, mm-hmm. weekly by millions.
Yeah, I get the point. And when you create those graphs on the end, it seems for you, like a complicated task, or it was, just click, drop, and drag and drop and stuff like this. How it looks like, because the effect is awesome. The effect is something which you really want to achieve, I assume. But tell me a little bit about the way to achieve it. So how you can do it.
Yeah, actually, this was weeks or months organic experience. Mm-hmm. When we are tracking, for example, we are starting with the infrastructure, when we just generated the first bill, and you see that 1/3 of your architecture is unknown. Mm-hmm. So you are starting to dig it out. Of course, there are some helpers like a trusted advisor. But yeah, when you see hundreds of warnings or errors,
yeah, it's just go through it,
Yeah, and they are coming day by day. So this is not the way just to operate. You need to figure out how to deal with those data from the better and the faster.
Okay, so another question, if you have a little bit more time, usually that kind of tools came with some kind of blueprints. Do you had there some blueprints, or you created like from scratch, or I missed that part?
Actually, very good question. Because I've started from Excel, I had years of experience with the data on Excel.
Yeah, and sure, like but you open.
Yeah, I know, but yeah, there are a lot of tutorials which shows you what the Quickside or Power BI is capable of. But once I found out on the YouTube some very good explanation what I can do with the Power BI, and it was set of on the analysis the players' data in the Hello game.
Okay, Hello game, yeah. Okay.
Yeah, and there was a huge data stream, okay, but the presenter showed how to combine them into something meaningful, and tada! From the millions of rows, I've saw only the 3 buckets with the numbers, and this was something what triggered it.
Okay, so basically it's more like a framework, and you need to work out the logic of data presentation by yourself. There is not something like you drop your data, it's make pre-analysis and showing you, okay, there are patterns and stuff like this. No, you just need to do it from scratch.
Actually,
I understand.
Yes, but some kind of data science knowledge also makes it handy. For example, statistics, because
sure.
When we are dealing with data, you need to know what to find. So some averages, some peaks, the basic terms, the border conditions. You need, for example, set up some level of cost you expect, or data amount you expect, and just to see what you can get, just by counting the rows, for example, counting the same times, just to play with those data.
I'm asking because usually that kind of software which is built in-house have some kind of gravity around it. So when you create this software and you put it on the table, for your people as a lead architect, actually, did they start to use it? Did they start to develop it, or they just use it? How the gravity around it looks like?
Yeah.
It's change organization, or it's just like wherever another tool?
Yeah. You need to introduce this into an organization, because it's very difficult for people to digest, and you need to find one person and start to show this person how to use it, explain it, spend some time, and allow him to generate it. And when this person will take it, find another one.
Let's go.
Do the 1 or 2 or 3 workshops. Sometimes you need to spend weeks or even months to teach the people how to operate. Another thing is a culture, like guys, we are dealing with costs here, so use the tags. If you are fair with the teaching with tags, of course we can use some kind of automation, like for example, we used a janitor monkey service, which was killed. That was very rude and harsh, but it was killed immediately, the machine, when it was raised up without tags, because our, let's say, our first experience was that, okay, we can give weeks of for people just to got used to use tags and send them warnings in emails. But
so
usually
you choose the way
warnings.
of shotgun way.
Exactly. So I said, stop it. Just kill it immediately when it's appeared without tags.
Okay. So
very quick way. Just after 1 week, everyone just got the knowledge.
So basically, your application changed a little bit landscape in your organization. The people approach to it and they use it and they are compliant with it, with the shotgun method. And when you realize that the granularity of the data from AWS, it's not enough for your use case, that in Cost Explorer, what was the trigger? Exactly, because usually there is exactly something like, we missed that. And after the definition of the small use case, we build a lot around it. But the first thing?
The first thing was that analyzing data was too slow. For example, if I have some idea in mind and I need to wait an hour, when, for example, to change the perspective, So this was no. We should invent something more fast. Okay, we can allow some percentage of or margin of error, but it will be okay. Then we can dig it out if this will be a difference. But from my experience, for example, our hourly bill and daily bill doesn't differ much. It was like a 1% or maybe 2%. So
I get the point.
just aggregate this, take a small data set, operate on it. And if you are, for example, if you are starting to find some weird behavior, then to dig it out, not from the beginning. And every data set, of course, is too big just to ingest into your mind.
Okay,
and that's why people just are scary.
Yeah, I thought so, because usually when it's regarding cost, and this top 5 or top 10, the most performant users, I'm not saying that the way that they spend money, but in the end, it's billable, so you can get this amount of money that they are spending. They usually are afraid, because they are true to innovation. They spend money, but in the end, somebody's going there and showing like, you are the first person here, and usually it's scaring people. And how you avoid that part in your organization? So the people start to, do less innovation, or opposite, they see if they're not doing anything, and they're not spinning the infrastructure, they are down on the end.
It's sometimes it's a shock effect, because if everything is all right, it's going well, so you can show the very beautiful charts, and okay, we can live with that. It's like a monitoring of the, I don't know, Jenkins job or something like this. Everything is green, but let's do the red day.
Yeah, the good day
during the lunch, and everything changed, and people starting to run like a holistic and looking for help. And if you saw them, for example, guys, here, you have a problem, because I use this technique also to analyzing the production monitoring. When okay, we have a big set of tools like Elasticsearch or like Splunk and so on, but without proper dashboard. This is only the lines. So you need to aggregate them to something more meaningful. For example, set up some percentage and even low percentage, like a threshold, and then just fire it up on the red and focus on that.
So basically, you're telling everybody to just break a little bit your infrastructure in, of course, the way that you can control, just to wake up people from coma of green.
Actually, yes. This is the concept of chaos monkey, and this is very good, because usually everything goes well. But in my experience, there was no need to do the, let's say, training fires, because we have a constant fires, and giving the information for quick data mining was very revealing for everyone.
Okay. Thank you very much, 𝐶𝐞𝐞𝐤.
It's a file, basically.
It was very good presentation, good chat here. I hope we answer some questions for the people who just want to build something and they are afraid that their organization will just not use the tools that they are bringing. And I think the tools that designed and created inside the organization have the biggest value, because they fit the most to the circumstances and environment that they are built for. And 𝐶𝐞𝐞, thank you very much for that. We slowly closing the survey that you have the link below for pizza and also for draw. I will ask guys here around, because we have the backstage heroes, which we didn't spoke about. So we have Maria and Kasia behind the scenes, who are, delivering you vouchers, they calculating answers, they doing all the hard work for us to spend lovely time here. So big shout for them, for Kasia and Maria, and they they prepared for me a list of people who answer correctly. And honestly, it's a good choice. 24 people we have here who fill the pool with the proper answers. So I will try to show you guys my screen and make the selection online. So for you to see, we'll pick random names, the beginning of your email address, and for those 3 people who will appear on the screen, they will get the vouchers for AWS services. Okay, so let me check which screen should I show you. Yeah, this one. Cool. Show full screen. What is the problem? So I hope you see my screen. Could you? Oh yeah, perfect. So we have a screen, and first one it's super testing job. I love the guy. Yeah, it's like perfect. Pick again, Nick Hope 86 and Filip Golonka. So 3 people. Maria or Kasia will contact you guys and share with you vouchers. Well, we're slowly going to the end of our meeting. I wish to thank you very much for Michał and Cosma, also the companies that you represent, the companies that are here in Małopolska region, in Kraków area. So Michał from Grape Up, our patron. Because of you guys, we had this opportunity to use this streaming solution and also to present live for you guys these presentations. And Cosma from Accenture, who provide for us some refreshments. And remember, this is a user group, so any one of you who are listening right now and you wish to share with us some story of you, some story of your solution, of your tools that you create in your organization based on AWS solution, just feel free, contact me over Twitter or on Facebook, wherever path is good, LinkedIn, and I will find a spot for you. We have a meeting just after the holiday season, I think. So another meeting is after holiday season. We will have maybe something before, but it's not sure yet. But for sure, after holiday season, we will have another meeting. And well, I will try, and I hope that this meeting will be in person. I don't know. We have 3 person, and that we will share the vouchers. And thank you very much for all of you for this 1 hour and 30 minutes of your time. I hope we share some knowledge and we see each other, I hope, in person next time. Michał, Cosma, thank you very much, guys, for the presentations. Thanks.
Thank you.
Thanks.
Cheers.